Alrighty. Step 2, collision response. Okay, so let's see what happens when two things collide. Oh, and also you can see here CPU usage, like I've got two CPUs, so one of them is all overloaded. Let's just give it a break. So that's definitely means that it can barely handle 200, and like it'd be nice to get it 2000 would be good, something like that. So we'll definitely need to optimize it, and you can see I've been splitting this video. Okay, whatever. Okay, that's the first time I've used that program, so I wasn't expecting that. So, paint, back to a fresh canvas. So we have two circles. There you go. And they collide. So what we want to do, so the midpoint is like there and there. Use another color now. So, want to pretend like that there is a sort of, see if I can get this, yeah, it's not too bad. So we'll pretend it's like a brick wall, well, a thin sheet which they then bounce off. So, and in order to bounce you need like a normal, so it'll be the normal, like doesn't matter which way it goes, which is perpendicular. So that normal is simply here to here, that vector just normalized. So, and these things will have their own velocities. So say this one is going that way, and this one is going that way. Yeah. So what we want to do is, well, we'll want to move these off each other. Move the circles, I mean, off each other. So we'll need to get, find this midpoint and just set it to be its radius away from that midpoint, and similar for the other one. Okay. Yep. So that's one part of it, and then the next part is doing this velocity reflection in this on this plane. Think of it like a plane. So what should I do first? I'll just do this how it moves it off each other first. Okay. So when a collision has occurred, you know what? I like this showing red thing. We'll keep this here. It'll probably be the case that it's hardly visible if we. But then I was thinking like maybe have it hit red and then fade back to white, but screw it. It's too much extra work. Okay, so we want to push them off each other. So we've got that difference. If that difference is 0, it's kind of like not much you can do. You basically have to wait for them to sort of get off each other, like not be in the exact same position. So I'm just gonna straight off, if the difference is not 0, so that means there actually is a distance between them. This is getting quite deep. Right, so that way we can actually divide by the length of the distance safely, because we know it's more than 1. I mean more than 0, yeah. Alright, so yeah, collision has occurred. Push circles off each other. They're getting too rough. Okay, so we need that midpoint. So that will be, well, we'll need to normalize this difference. So yeah, we'll need the normal. Okay, so that will be a multiplication of the distance, so we'll want a multiply function. difference. Difference to x, difference to y, and the inverse square root. Square distance. What long lines we're getting. Anyway, so the midpoint will be, so say from circle 1 to circle 1's position plus its radius times the normal, since the normal is going from circle 1 to circle 2, since we did it like that. So that's going to be another utility function, I think. Wanna add scaled xy, or x1, y1, x2, y2, k. Speaking of Y2K, today I heard like this story that like during the Y2K bug crisis, in quotes crisis, like things needed to be certified as Y2K compliant, like it was a law, and like this hospital had to spend $5 million to get all their equipment Y2K certified. It's bloody ridiculous. Anyway, that was a bit random. It's just something I heard today which really surprised me. Try not to be dumb. Yeah, that's the take-home lesson. Try not to be dumb and fall for stuff like that. Okay, so midpoint is add scaled of circle 1 dot x, circle 1 dot y, to normal, x normal dot y, multiplied by circle 1 dot radius. So that gives us the midpoint. Yeah. No, it doesn't. No, it doesn't. Oh my god. Where is the midpoint? It's gonna be this radius. Okay, it's gonna be, so we have the distance, say this is the distance, and then circle 1 sort of, get this thing, circle 1 is like that, and circle 2 is like that. So we've got this radius, we've got this other radius. We need to like do something with these numbers. Okay, so this position says, pretending this is 0, this position is going to be the distance minus circle 2's radius. So if we know this number and this number, it's just that minus that to give us this, and then we like, or add them together and then divide by 2 to get the average. Right. So okay, so circle 1 radius plus that other thing. What was it? Distance. Okay, so it looks like we actually need the distance. Okay. Distance equals this, and hell if I'm ever gonna do a square root unnecessarily. Yep. Distance minus circle 2 dot radius. Add those things together and divide them by 2. That's quite a long line. I'm gonna make it a bit more readable. Yep. God. I don't have auto indent turned on because it's like it gets it wrong sometimes, and I'll just use Control D. Alright, so that gives us the midpoint, and then we can now sort of, yeah, do another add scaled to get us circle 1's position. So, we wanna like assign a vector, like, so it doesn't have to be 2 lines. Screw it, I'll just have a temp vector. The reason I'm not like just being able to writing these functions so I can just do that, multiply that vector by that, is because why is that? Where do I ever need to not do that? Okay, I'm changing all my code. v1, v2, v1.x plus v2.x. Yeah, and I'll pause this while I do that. Whoops, gone over time, sorry. Alright, since YouTube takes videos up to 15 minutes, I'll just end it here. I won't like do a second 10-minute part. So, see you later.